We have understood what is feature engineering and what all techniques it consists of. So now let's deep dive into the each and every method that we have mentioned, each and every category and then methods that we have mentioned under feature engineering, which is the step 4 of the supervised machine learning process. So first we will begin with feature selection. Under the feature selection, we will start with univariate selection. Univariate selection. To do the univariate selection, you have to use statistical inference or inferential statistics. That's what we have to use, and specifically statistical tests from inferential statistics. That's where we'll start it. That's where we'll begin. We'll begin that. So univariate selection. And to do the univariate selection, we require a statistical significance tests or statistical tests, or we can also call it as a statistical procedures to do the statistical tests and to find out the statistical significance of the relationship between the features. That's what is that. So what all tests we are going to do? G test, as we have discussed earlier. What is G test? G test is a statistical procedure used to test hypotheses about population means when the population standard deviation is known. And we have T test. The T test is a statistical procedure used to test hypotheses about population when the population standard deviation is unknown or when the sample size is small. And ANOVA, analysis of variance, or F test, is a statistical procedure used to compare the means of two or more groups. It assesses the variability between the groups and within groups to determine if there are significant differences among the means. We have a chi-square test. The chi-square test is a statistical test used to assess the independence or association between two categorical variables. And the two-case test or two-case honest significance difference test is a post hoc test performed after conducting an ANOVA to determine pairwise differences between group means. So now let's begin with a G test or Z test. Okay, so let's begin with the univariate selection. Under this, we will do a Z test. This is our first statistical test. We will explore this. We'll begin with the confidence interval. We will understand normal distribution. Then we will understand standard normal distribution. After that, we will get into the details of G test, G score, and we will do an example for this. For that, how confidence interval is very important for data scientists. If you're not sure, that also I will explain. But confidence interval is very, 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 very important for a data scientist to become or to make an accurate model, to make a model which can perform well. Okay, so let's begin. Uh, so far, I think you might have seen frequency tables, histograms, box plots, and standard errors are always to understand the potential error in a sample estimate. So confidence intervals are another one. That's it. So the confidence interval, exactly the confidence level. First, we'll see what is confidence level. Confidence level, the percentage of confidence intervals constructed in the same way from the same population. So that are expected to contain the statistic of interest. I know it's not clear for you. I will explain. Don't worry. Then interval endpoints. Just grasp the terminology for now. What we have used: confidence interval, confidence level, now interval endpoints. The top and bottom of the confidence interval. Interval endpoints are nothing but the top and bottom of the confidence intervals. So there is a natural human aversion to uncertainty. People, especially experts, say, I don't know, far too rarely. Analysts and managers, while acknowledging the uncertainty, nonetheless place undue faith in an estimate when it is presented as a single number, a point estimate. Presenting an estimate not as a single number but as a range is one way to counteract this tendency. Confidence intervals do this in a manner grounded in statistical sampling principles. So, confidence intervals are a way to estimate a range of values that a true population parameter is likely to fall within based on a sample of data. So imagine you are trying to estimate the average height of all people in a country, but it's not feasible to measure everyone's height. Instead, you take a random sample of people and measure their heights. So now the average height of this sample will likely be different from the true average height of the entire population. Yes or no? Obviously, yes. I'm repeating, the average height of this sample will likely be different from the true average height of the entire population. So, to estimate the range of values that the true average height might fall within, you can calculate the confidence interval. That's what you see here on the screen. A 95% confidence interval, for example, means that if you repeat the sampling process many times and calculated a confidence interval for each sample, you would expect 95% of those intervals to contain the true population average. So, the confidence interval is typically calculated using the sample mean, a sample standard deviation, and the size of the sample, along with formula that takes into the account of variability of the data and level of confidence desired. For example, if your sample of pupil if your sample consists of 100 pupil has an average height of 1 centimeter, let's put it here as 170 centimeters, 10 centimeters, and a standard deviation of 5 centimeters. So one standard deviation is 5 centimeters. You might calculate a 95. Then see here, you will have exactly at the center, it's 170 centimeter. Then one standard deviation, two standard deviation, and three standard deviation. So 175, 180, and 185. And here 165, 160, and 155. So this means that so then let's take a 95% confidence interval. We might calculate a 95% confidence interval of 165 centimeters to 175 centimeter. So this means that if you repeated the sampling process many times and calculated a confidence interval for each time, for each sample, you would expect a 95% of those intervals to contain the true average height of all people in the country. I hope you are getting my point. If not, I will repeat it again. Confidence intervals provide a way to estimate the uncertainty associated with a sample estimate and to assess the precision of the estimate. They are useful for making inferences about a population based on a sample of data and comparing different groups or treatments. So now, if you take this example, let's take, we have done our sampling and we got the average of 300. Okay, let's take, this is our average. It's a 300 seats that BJP is gonna win in 2024 election. Okay, that's what we have. That's what the output we got from our exit polls. Then this is our exactly the average is at the center. That's at 300 seats for the BJP. Then we got the standard deviation, and with one standard deviation of 10. Then with this here, exactly the mean is 300, and lower limit is 290, because we have gone for the 95 percentage confidence level. So you got 2.5 percentage outliers and 2.5 percentage outlier, and upper level. So we have told na confidence levels or limits. So upper side is 310 and lower side is 290. Okay, so now when we say 95 percentage confidence interval or 95 percentage confidence, we say that there are 95 percentage chance that polls results BJP seat count will fall between 290 and 310. Let's take, this is what the outcome of our exit polls, and we are in 2024. Let's imagine we are in 2024. Then results were announced. After announcing the results, BJP got 304 seats. That's what the number of seats. This is basically a proportion. True number of seats that got by the BJP is 304, and we were telling that we were 95 percentage confidence that the BJP will get the true number of seats that BJP will get would lie in between 290 and 310. We are 95 percentage confidence that the actual seats that will be gotten by BJP after announcing the results will lie between 290 and 310. So that's what is our confidence interval. And there are chances remaining 5 percentage it may miss. It's not that it's not that they'll damn sure they'll get it in between. No, it is uncertainty. There is an uncertainty. Sometimes it may get into the outliers. Either sometimes they may get 285, sometimes they may get 320. Still that goes up. That can happen, but the number of times that can happen is 5 percentage. The number of times it would fall in between confidence interval is 95 percentage. So that's what we say. The confidence interval is typically nothing but how many times. For example, if we repeat this experiment, if we repeat this sampling process many times and calculate a confidence interval for each sample, you would expect 95 percentage of those intervals to contain the a true or actual number of seats that will be gotten by the BJP.